This basic math skills self-test number 3 is very similar to 1 and 2. Same topics are going to be covered. We've just changed the problems a little bit. Okay, you have 20 different problems for you to try. When you see a new problem, click on the stop sign and that'll pause the video if you're watching this on YouTube. Try to work out the problem on a piece of scratch paper and then click on the go sign and you'll see the problem worked out. Number 1, you want to turn 0.725 into a fraction and then simplify your answer. Click on the stop sign. Alright, let's see how you did. Well, 725, that's going to be our numerator because we don't have to pay any attention to the decimal when we're figuring out what our numerator is. But the decimal is very important when we figure out what the denominator is going to be. Here we have 3 numbers to the right of the decimal. That means we're going to have 3 zeros in the denominator. This is called, if somebody were to say what this is, they would say, oh, it's 725 thousandths. And here is the fractional form, 725 thousandths. All right, we'll take a look at this and we say, let's factor this. We know that 25 will go into 1,000 40 times. So 40 times 25 will give us 1,000. And then we take a look at this and we say, how many times will 25 go into 725? All right, we know that 29 times 25 is going to be 725. Now, we have a 25 in the numerator and we have a 25 in the denominator. They cancel with each other. They don't just go away. They don't become 0. They don't become nothing. They become the number 1. And that's pretty important sometimes. Now, we have 29 times 1, so that's just 29. And 40 times 1 is 40. And I don't see a way that we could factor this any further. So what this means is, if we did the top in, bottom out, if we divided 40 into 29, we would come up with 0.725. Number 2, you're going to turn 7/16 into a decimal. Click on the stop sign. Okay, let's see how you did. It's just a long division problem, so our 7 goes in and 16 goes out. We know that 16 will not go into 7, so we'll just put a 0 here and a decimal. Our answer is going to be smaller than 1 because 7/16 is smaller than 1. Now, 16 will go into 74 times. And 4 times 16 is going to be 40 plus 24 is going to be 64. What I just did was, I know that 4 times 10 is 40, and 4 times 6, is 24, so then I just added 40 and 24 in my head. And so we now do the subtraction. We wind up with a 6. 16 will not go into 60, but we do know that it will go into 60, so it'll go 3 times. And 3 times 10 is 30, 3 times 6 is 18, that's 48. I do my subtraction, and I wind up with 12. I know that 16 will not go into 12, but it will go into 120, and it will go 7 times. 7 times 10 is 70. 7 times 6 is 42. 70 plus 42 is 112. That leaves me with 8 left over. I know that 16 will not go into 8, but it will go into 80 exactly 5 times. And this terminates because I now have a 0. So my answer is 0.4375. Okay, let's see how we did. The answer that we got for number 2 was 0.4375. And if we just shift the decimal 2 places, that turns it into a percentage. And a percentage means it's over 100. So we have the answer 43.75 over 100. If we did the long division on this, we would get 0.4375. Okay, all units are in feet. The rectangles are proportional. What is the length of x? click on the stop sign. Alright, we have proportional rectangles. We know that. We've been told that. So we need to find out the length of x. We need to know what this length is right here. And so a couple of ways we can do this. We can compare the ratio of the length of this side to that side with the length of this side to that side. And it would look something like this. We can put 4 over 6 equals x over 11. And then we cross multiply and we'll get the same number. So 4 times 11 is 44, and 6 times x is 44. Now we have to solve for x. So we have 6x, and it doesn't matter if we say 6x equals 44 or x6 equals 44. It's just more traditional to say 6x equals 44. So now we know that we have 6x equals 44. Whatever we do to this side, we need to do to this side. So let's divide both sides by 6. The reason we're dividing both sides by 6 is so that we get x on one side by itself. That 6 cancels with this 6, making it a 1 and making it a 1. 1 times x is x over 1, and x over 1 is just x. So now we have x equals 44 over 6. And then I would look at this and immediately say, well, I can cut 44 in half to be 22 over 3. And 44, 6, and 22 thirds are equivalent fractions. That is, if we did the top end, bottom out on both of these, we did the long division, we would get the same answer. And so now I look at this. I know that 3 will go into 22 7 times. And that will leave me with 1 left over, and I'm dealing in thirds. So x is going to be 7 1/3 feet, or 22 thirds feet. Okay, number 5 uses the same drawing. So now what you're going to have to do is remember what you had for the answer for number 4, and that would be 7 1/3 feet, or 22 thirds feet. They're the same amount. What is the area of the larger proportional rectangle? Click on the stop sign. Alright, you used the information in number 4 to help you figure out what the length of x was, and now you need to use that information to find out what the area of the larger rectangle is. Area, the formula for area is of a rectangle is just length times width. And so we're just now going to plug in those numbers. So, and that's what's nice about a formula, is you just plug in the numbers. And so we have, I'm going to make it 22 thirds, that'll be easier, times 11. And these are feet, and this is feet. And I'm just multiplying a fraction times a fraction. I could just put that over 1 if I wanted. So I have 22 times 11. And 22 times 11 is 242, and then 3 times 1 is 3, so it's 242 feet thirds, 242 third feet. Alright, so now what I have is, this is my answer, but that's not a very useful answer, so I need to simplify that a little bit. How many times will 3 go into 242? And so we come over here and we say top in 242 and 3. 3 will not go into 2, but 3 will go into 24 exactly 8 times. And so that gives us 24. We do the subtraction and we wind up with 2. 3 will not go into 2, so we'll add a 0. We're at the end here, so we'll put a decimal. 3 will not go into 2, but 3 will go into 20, and it'll go exactly 6 times. And so that gives us 18. We do the subtraction, and we get 2 again. And so that tells us that we're going to be in a loop here. And so 3 will go into 20 exactly 6 times, and we wind up with that being 18, and that's 2, and so we know that it's just going to be 80.666666. So we'll just put 80.666, put a line over that, and we are dealing with feet squared because we're talking about area. So the correct answer is going to be 80.666 feet squared, and this is also 2/3, so we could say that our correct answer is going to be 80 and 2/3 feet squared. All right, number 6, the square root of 22.3 is between what two consecutive whole numbers? Now, refreshing your memory here, consecutive just means that they come in order, like 7 and 8, 9 and 10, 15 and 16. And so click on the stop sign. All right, let's see how you did. The square root of 22.3 is between what two consecutive whole numbers? Well, we're going to pick the square root of 16 and the square root of 25. It's hopeful that you can see that the square root of 22.3 falls somewhere between the square root of 16 and 25. Now, the square root of 16, that's just 4, and the square root of 25, that's just 5. 4 and 5 are consecutive whole numbers. So the square root of 22.3 is somewhere between 4 and 5. Okay, the triangles are proportional. What is the angle measure of the unknown acute angle? Click on the stop sign. All right, what they're asking is, what's this angle right here? And so if we know that these are proportional, then we know that this is 90 degrees, and we know that this is 22 degrees, and we also know that all triangles, the internal angles of all triangles, sum to exactly 180 degrees. So what that means is this angle right here that we'll call x, because we don't know what it is, and that's the traditional thing that we use when we don't know something. We know that 90, and it's degrees, plus x degrees plus 22 degrees equals 180 degrees. If I subtract 90 from each side, I wind up with x plus 22 equals 90, because I've just subtracted 90 from each side, so 180 minus 90 is 90. And now if I subtract 22 from each side, I wind up with x equals 68. And we're talking about degrees. So the correct answer is 68 degrees. All right, make a sketch of the coordinate plane, then sketch a circle that has a radius of 1.5 and is centered at the ordered pair 3, 3.5. Click on the stop sign. Okay, I look at this and I think, all right, the Cartesian coordinate plane that I need to make is all going to be in the first quadrant. I won't be using the second quadrant, third quadrant, or fourth quadrant, simply because everything is going to be taking place in the first. My ordered pair, the center, is located at 3, 2, 3, and 3.5. So I'll sketch here 1, 2, 3, and 0.5 would be somewhere about right there. So the center of my circle is going to be here. The radius of my circle is going to be 1.5, so I'm going to go down 1.5 to about here. That dot will fall on the circle, and then I go over 1.5. This dot will fall on the circle, and then I go up about that same amount, and I'll go over about that same amount. What this has done is give me a target. So when I freehand sketch my circle, I have some points that I can hit, and there we go. I now have a circle located at 3, 3, the ordered pair, with a radius of 1.5, and it's all within the first quadrant. Okay, number 9, it's pretty straightforward. Just multiply a bunch of fractions. Click on the stop sign. All right, let's see how you did. Multiplying fractions is pretty easy. You simply just multiply the numerators, and then you multiply the denominators, and then simplify. So 7 times 3 is 21, times 1 is 21. So our numerator is 21, and our denominator, 8 times 4 is 32, times 3 is 96. So we're going to have 21 over 96. And now we need to simplify this. I look at it and say, I know that 3 is a multiple here and 3 is a multiple here because 3 times 7 is 21 and 3 times 32 is 96. I now have a 3 in the numerator, I have a 3 in the denominator, and my final answer is going to be 7/32. Number 10. It's just a division by a fraction. Click on the stop sign. Okay, dividing by a fraction. Let's see how you did. So we have 9 divided by 1/2. That's the same thing as 9 times 2 over 1. And so we could make that a fraction. Now we're just multiplying two fractions. So 9 times 2 is 18. And 1 times 1 is 1. And any number over itself is just that number. So the correct answer is 18. Refreshing your memory, we'll take a quick peek here at why it is that we flip over the dividing fraction. If I have 1/2 divided by 1/2, you know that 1/2 will go into 1/2 exactly one time. So the answer to this is going to be 1. But if I have 1/2 divided by 1/2, and I flip over the dividing fraction and then multiply, I should still get 1. So I have 1/2 times 2 over 1, having just flipped over the dividing fraction, and now I multiply. 1 times 2 is 2, and 2 times 1 is 2, and any number over itself is 1. All right, number 11. What is the area of the figure shown? Click on the stop sign, give it a whirl. Okay, the figure shown is called a trapezoid. The formula for finding the area of a trapezoid is base 1 plus base 2. All of that multiplied times the height, and all of that divided by 2. That's the formula. This is a base. The bases are just your parallel lines, and this is another base. So it doesn't matter which one you call base 1 or base 2. You simply just add these together. And so 4.5 plus 6.5 is 11. Now I have 11 times 3.2. And all of that divided by 2. 11 times 3.2 is 35.2. And all of that divided by 2. And this is my final answer is going to be in feet squared. So I could be, it would be good form to go ahead and keep the measurements, the units connected to this. So now I have 35.2 divided by 2, and that's going to be equal to 17.6. And my answer is going to be feet squared. So my correct answer is 17.6 feet squared. All right, number 12, make a sketch of the depiction below and then reflect it across the x-axis. Click on the stop sign. Okay, let's see how you did. Well, this is our x-axis, and we're reflecting it across the x-axis, so you should have made something that looks like that. And if you did that, you're getting it right. Number 13, sketch the drawing below and reflect the figure across the y-axis. Click on the stop sign. Okay, this is our y-axis, and we're going to reflect it across it. So I'm going to attempt to freehand something that shows a reflection. So looks something like that. And so if you drew something that looks like that, you're getting it right. All right, what is the area and perimeter of a right triangle that has two legs that are 4 feet and 5 feet and a hypotenuse that is 6.4 feet? Click on the stop sign. Okay, it's my strong suggestion that you always make a sketch. So let's see, it wants to know we have a right triangle, and it tells us that one of the legs is going to be 4 feet, and one of the legs is going to be 5 feet, and our hypotenuse is going to be 6.4 feet. Now, so that's feet, and that's feet. Then it says, let's tackle the easy one first. That'll be the perimeter. What's the perimeter? Well, the perimeter of anything is just you total up all the sides. So it's the edge. So 4 plus 5 plus 6.4 is going to be 15.4. And perimeter is just length, so it's going to be feet. So that's our perimeter. Now, it says find the area. Well, in order to find the area of that, we need to know the formula. And the area formula for a triangle is base times the height, all of that divided by 2. And it's a formula, so we just plug in the numbers. So it's 4 times 5 divided by 2. 4 times 5 divided by 2 is going to be 20 divided by 2. And how many times will 2 go into 20? They go exactly 10 times, and we're talking about 10 feet squared. So the correct answers are 10 feet squared and 15.4 feet for the perimeter. Sketch a triangle and label 3 of its main parts. Click on the stop sign. Okay, well, we'll sketch the triangle. See how you did. All right, this is a leg. This is a leg. This is the hypotenuse. This is the area. This is a right angle. This is an acute angle. This is an acute angle. Those are some of the main parts of a triangle. Okay, here we're going to be adding and subtracting positive and negative integers. Click on the stop sign. All right, we're going to start off. Let me just draw a number line here. We're going to start off at negative 11. And then we're going to add negative 10, which means that we're going to go to negative 21. And then we're going to add 32, which means that we're going to go in this direction on the number line. That'll take us from 21 to adding 32 will take us back to 11. So we are at 11 on the number line. And now we're going to take away a negative amount. Taking away a negative amount is a positive thing. So one of the ways that I remember that is I will use this minus sign right here to turn this into a plus sign. And if I use it, it goes away. So it's no longer there. And so now I'm at whatever my answer was, plus 9. And 11 plus 9 is going to move me in this direction. And that's going to make it the final answer being 20. Perhaps another way that might help you remember how to deal with taking away a negative thing, the way I do that, another way that I do that is taking away a negative thing is a positive thing. All right, what are the measurements below? Click on the stop sign. Well, let's see. The distance from here to here is 1 inch. It's divided into 16 equal marks, and those 16 equal marks are called sixteenths. And by the way, the sixteenths, the marks that are between here, are exactly the same 16th marks that are between 1 and 2 and between any two numbers on the number line, or on the ruler. So what we can do here is just count them. We have 1, 2, 3, 4, 5, 6. We have 6 sixteenths. Well, 6 sixteenths can be simplified, and 6 sixteenths equals the equivalent fraction of 3/8. Perhaps what you might notice is that the distance from here to here is 1/8. That's 2/8. That's 3/8. All right, B is 1 16th, 2 16ths, 3 16ths. It's 3 16ths. We can't simplify 3 16ths anymore. So it's 3 16ths of an inch. That's what those two little marks mean. And now we'll take a look at the next one. Here we have, this is 1 inch. And 1 inch is the same thing as 16 sixteenths. So here we have 17 sixteenths, 8 sixteenths, 9 sixteenths. 1 inch is the same thing as 16 sixteenths. So here we have 17 sixteenths, 18 sixteenths, 19 sixteenths, 20 sixteenths. So we could say that this is 20 sixteenths. That's not the best form, and so perhaps you notice that you are at 1 and 1, 2, 3, 4 sixteenths. So we're at 1 and 4 sixteenths. However, 1 and 4 sixteenths inches can be simplified, and we can simplify that to 1 and 1/4, because 4 sixteenths simplifies to 1/4, and these are inches. Now, here we have D. We are at 2, and we have 1 sixteenths, 2 sixteenths, 3 sixteenths, 4 sixteenths, 5 sixteenths, 6 sixteenths, 7 sixteenths, 8 sixteenths. We are at 2 and 8 sixteenths. 2 and 8 sixteenths simplifies to 2 and 1/2, and we're dealing in inches. So if you got those right, you know how to read a ruler. All right, how many minutes are in 1/8 of an hour? Click on the stop sign. Okay, let's see how you did. Well, there are 60 minutes in an hour, and we're going to multiply that times 1/8. And we can put 60 over 1 just to make it a fraction. Now we're multiplying 60 minutes in an hour, so we have 60 divided by 8. That's now just a long division problem. So we come down here, 60 goes in, 8 goes out. 8 will not go into 6, but 8 will go into 60. It'll go 7 times. 7 times 8 is 56. We do the subtraction. That gives us 4. 8 will not go into 4, but it will go into 40. We reach the end here, so we place the decimal, and 8 will go into 40 exactly 5 times, and we terminate. So the question was, how many minutes are in 1/8 of an hour? 7.5 minutes. Okay, number 19. Paula charges $10 per hour for her handyman services. If she works 6 to 11 hours per day for 4 days, what is the range of her gross pay? Click on the stop sign. Okay, let's see how you did. Refreshing your memory, gross pay just means the total amount that she got, and range means what's the low number to the high number. So let's see, let's just kind of chart this out. Let's get it organized. She makes $10 an hour for her handyman service if she works 6 to 11 hours a day. So let's say on day 1, she works either 6 or 11 hours. And on day 2, she does the same thing, 6 to 11 hours. Day 3, she does the same thing. And day 4, she does the same thing. Well, so 6 times 4, number of days that she worked, will be the minimum number of hours that she worked that week, and that's 24 hours. And if we want to know what's the maximum number of hours that she could have worked, we can just multiply 44 times 4, the number of days that she worked, and we'd get 44. So she either worked 24 hours or 44 hours or somewhere in between. The range of the hours that she worked was 24 to 44, but she makes $10 an hour. So we'll multiply those times 10, and so we have $240, or we have $440. So Paula either makes $240, or she makes $440, or somewhere in between. The range is $240 to $440. Number 20. We're going to have to multiply a little bit here and divide. So click on the stop sign, give it a whirl. All right, let's see how you did. First thing we need to do is that which is in the parentheses. So we multiply 5 times 7, that's just 35. And 6 times 9, that's 54. And we're going to divide that by 2.7. A couple of options here. We can turn this into a fraction. We could turn this into a decimal. I think I'm going to multiply this times 27 tenths. We can turn this into 27 tenths. 27 over 10. And then to multiply, or excuse me, to divide by a fraction, I just flip it over. So now this is going to be times 10 over 27. And this one's pretty easy. 35 times 10 is 350. and my denominator is going to be 54 times 27. That's going to be 1458, 1458. And I simply now can simplify this, or I could do the long division process, top in, bottom out. And if you do the long division process on this, you should come up with the answer of 0.2400, and goes on after that. So correct to 2 decimal places. Our answer is 0.24. That's the end. You're now ready to try other basic math skills self-tests. You may contact me at alanmorris@yahoo.com.